Hello, I am Joey, a software engineer at Microsoft and the current maintainer of the Patina component infrastructure. Today, I will be walking you through some of the common developer workflows to easily and quickly test Patina or Patina components on one of our virtual platforms in Patina QEMU. A successful boot to the UEFI shell for both Q35 and SBSA is required when contributing to Patina, so knowing how to quickly iterate and test with these platforms is invaluable. My focus will be on how to boot a locally compiled platform Patina Dixie core binary with custom changes to either a Patina component, the Patina core code, or the core binary itself. We will use the build and run Rust binary script, which utilizes the Patina firmware patcher to compile the Patina Dixie core and patch it into the FV without needing to recompile the EDK2 firmware. To get started, you should create a new directory that will contain the repositories necessary for this work. In my case, I created at source/video. However, you can name it whatever you like. Within this folder, you will need to clone Patina QEMU, Patina firmware patcher, and Patina Dixie core QEMU. If you plan on making changes to core code, you will also want to clone Patina. Our first step will be to prepare Patina QEMU and build the firmware so that it can be patched consistently. If you're not familiar with EDK2 style workspaces and how they build, it is my suggestion that you use workspace setup.py. As always, though, the very first thing that we want to do when working with Python is create a virtual environment. So let's do that now. The command may be slightly differently depending on your system, but for me, it will be py tac-m vnv, and then the name of the VNV that you want to set up. Once the virtual environment has been initialized, let's go ahead and activate that. So it'll be whatever the name of your VNV is, scripts, and then activate. If you're on Linux, that command will be slightly different, so just look that up. So now that we're in a virtual environment, let's go ahead and just execute the workspace setup script, and it will begin to ask us a couple of questions. You may answer these questions differently depending on what you're doing. For me, we will be using Q35, and we want to build a new QEMU UEFI image from source because we have not built that. It is asking about different Python versions. Let's go ahead and use our virtual environment. For me, that is number 3. As soon as we selected our Python version, it went to automatically install our pip requirements. So you can see here the command that it is calling, pip install, with our pip requirements. After the pip requirements were installed, it moved on to calling the commands necessary to build our firmware. So the first thing that it is doing is calling Stewart setup, which initializes a lot of our submodules. So we can see that done here. And then next it's asking if we would like to run Stewart update or not. I would answer yes. As the script says, this is necessary to update external dependencies in your workspace that are used during the build process. It is required to run at least once in a new workspace. So that's why we clicked yes. You will see that it goes through and it is able to update, in my case, 11 different external dependencies. It then immediately moves on to running Stewart build, which is building our firmware. If everything's set up correctly, this command should pass and a QEMU window will pop up, taking you to the UEFI shell. Once you close that window, the tool will exit because your workspace is now successfully set up. Next, we need to set up our Patina QEMU workspace to be able to patch in the Patina Dixie core binary. We can do that using the same exact script, so let's go ahead and run it. It will once again ask us which platform we are using. I selected Q35, so I'll select that again. This time it detects that the platform is built, so it's asking us if we are looking to patch the Patina binaries. Since we are, we'll go ahead and press enter. It asks us for our path to the Patina firmware patcher. Due to how we cloned our workspace, it is one folder up, so let's go ahead and provide that path. It then asks us for the Patina Dixie Core QEMU binary. Let's go ahead and provide that. It is also one directory up. And finally, it is asking if there are any more repositories that we want to patch into our Patina Dixie core. There are. We want to patch the Patina repo, so we'll do that. It's one directory up. And we have no other path, so we'll just press enter. We can review the configuration if we want. I think the important thing to note is that not only is it printed here, but it does create a folder with all of this information so that we do not have to type it in every single time. To me, the data looks good, so let's go ahead and press enter. This tool starts off by building Patina. It's built. It is now patching the binary, which it did in 4 seconds, and then it kicked off a boot. So you can see the logs coming through. And you can't see the QEMU terminal on my screen, but we have successfully booted to the UEFI shell using a patched version of our Patina Dixie Core QEMU binary. Just to show that we really do not have to type in all of that information every single time. Once this file is created, we'll go ahead and just run the script once. It will ask us which platform we are booting because this supports having configurations for Q35 and SBSA at the same time. We will click Q35, we press enter once, and we can see the process has started. I won't sit around and watch it run all the way, but you can immediately see within 10 seconds or so, we have started booting. At this point, with Patina QEMU set up, we can make changes to Patina or Patina Dixie Core QEMU, and as long as we build with workspace setup.py, those changes will be applied and we'll be able to test them. So next, let's actually see this in action. We'll go through 2 examples. We'll make a change in Patina Dixie Core QEMU repo and watch that propagate to the flash, and then we'll make a change to the Patina repo and watch that propagate to the flash. So we'll start with Patina Dixie Core QEMU. We'll actually just add a panic statement here, and we'll see what happens. I don't think logging is actually going to work because we will not have ran our logger yet, but it might. We'll see. And I will skip through this once it starts just because it will be a little bit slow to compile. Okay, and we're back, and we can see that the log message did actually work, and you can see that we successfully panicked. So we are getting our panic message, panicked@bin q35dixiecore.rs, line 108. That's exactly what we said with our panic message, uh-oh. And then we get a stack trace. So let's go ahead and do the same, this time with the Patina crate itself. So we'll go ahead and remove that and save this and move on over to the entry point. Yeah, let's go ahead and click here. And let's add a panic in our entry point. We will do it, we'll do it immediately, and we'll see what happens. Uh-oh, times 2. So we'll go ahead and run it again and do a quick skip for it to build and run. Okay, so we did successfully compile and boot, and you can see we panicked exactly where we expected to panic at. So we got our panic at line 369 with uh-oh times 2. So you can see that any changes applied to either the Patina repo or the Patina Dixie Core repo were successfully applied. Using this developer workflow should allow you to quickly iterate and test changes made to any crate within the Patina Dixie Core QEMU binary. I hope this video helped. If there are any questions, please reach out to the Patina community. Thanks again.